Right, so part A now says to construct a fully labeled tree diagram to represent all the possible outcomes. Now, this was taken from the weekly notes number 10, and I think it's example 10.6, I think. So check it out. So it is done already, it is solved already. Okay, so we're just going to analyze it. I'm going to capture this. And then head towards, yeah, so if you go in the weekly notes number 10, you will see that it is done already. But just to give a sense of we are doing it live, I covered oh, and I can do something else. I covered the answers. So that's the template. If you look in the weekly notes, that's the template. So now it just came to me there, side by side. Okay, let me see all these little ideas. You cannot really do that on the chalk and board. So let's put this. So, okay, and that's where we are. All right, that's where we are, right? Coming on here. All right, that's the answer. And oh, let's go back up again and capture the question itself, the information. So this information, you see, is a lot of words. Although you see some numbers, they're like 2, but everything there can be converted to words. Bracket, the probability 0.26. So you can put ZEROPOINT full stop F. So everything there can be converted to words. Always bear that in mind. Okay, so that whole paragraph can be converted to a diagram. It's called a tree diagram. Something that is actually happening can be converted to a diagram. All right, Bob coming to work, you know, and his activity of coming to work can be represented on the diagram. Okay, and here's the template. Let's start with the first section. Let's analyze the first section. The first section normally will be coming in the first sentence, if you want to put it that way. So as we see now, the information will convey when and where the event is happening. The event will be a verb, arriving. Okay. Arriving. The probability thereof. P for probability, the probability that Bob arrives to work late on a Wednesday. This sentence can be constructed into a diagram. And here it is. All right. Here it is. First section is called a Wednesday. What is happening on a Wednesday? What can happen? Not what is happening, sorry. What can happen on a Wednesday? Right. There's a probability. Okay, well, I put early first. You can put late first, you know. All right, you can put late first. So it doesn't mean you can put early up there and late down there. You can put late up there and early up there. So there's a probability that he coming early or he can come late. Okay. Now remember we said or now the symbol for or in probabilities is to add, and the symbol for and is to times. The operation for or is a plus, and the operation for and is multiply. We always remember that. So remember what I'm saying. You can either come late or early. All right. The probability of him coming to work early or late, the probability of him coming to work late on a Wednesday, late on a Wednesday, that information was given. It was provided 0.26. All right. The probability of him coming to work late on a Wednesday, you see that? All that is a simple, you see the sentence and look at the diagram. The probability of him coming to work late on a Wednesday is equal to, all right? So that is what math, that is why maths is important. So always take your maths class very serious, because what it will do, it will make you a rounded analyst, you know, a rounded person that can, you know, make decisions, use numbers and also words to make decisions, policymakers and so forth. So you see what happened in it? The probability that Bob arrives to work late on a Wednesday is 0.26. You have a sentence. That sentence can be converted to a diagram. Okay, a lot of engineers does that. For those that are thinking of engineering and even economics and so forth, biology, chemistry, you know, that is why, you know, fundamental starts in basically all your disciplines, because you need it for practically anywhere you want to venture in the academic world. So here it is. The probability that Bob coming to work late on a Wednesday is equal to 0.26. Here it is. Okay. Now, coming to work late implies the possibility of coming to work early. It's obvious. Okay, so you can either come to work late or, right, because now, remember we said or, the sum of the probabilities across any node, that's what you call, that's a node, here it is, those are the points that are called nodes. The sum of the probabilities across any node is equal to 1. Exactly 1, nothing more, nothing less. I repeat, that's a fundamental rule for the tree diagram. The sum of the probabilities across any node, late or early, is only 2 of them, all right? Must be exactly 1. So because it's just 2 of them alone we have, if you have 1, you can get the order by subtracting from 1. Okay, so here it is, the first section of the tree diagram. 0.74 plus 0.26 must be equal to 1. So apply that now to the, you should have the assignment open also, you know, I don't have it because I'm looking at time management on my screen, but you should have the assignment number 12, number 12, open now and see if you can relate what we just did there to the first sentence in the assignment. What is the name of the person in the assignment? In the example is Bob. Exactly. So also try to do it with your pencil and pen, right? Do your note, your Wednesday. Was it Wednesday and Thursday? What it was? Monday and Tuesday. So Wednesday here is Monday in the assignment. So also do your Monday, do your note, do your line, your pencil, you know, your scrap quickly, probably up early, late. Was it 0.26? What was it? 0.12, 0.12. Was it the same late or early? The first sentence. Right, so therefore you P of L, you should have your point, you know, and so forth and so forth. All now so. Please do that. Okay.